Good evening, Professor and students. This is from topic 14, stoichiometry, video C, mass-based calculations. And we are doing let's practice number 4, question number 3.
We're going to take we have 2 atoms of oxygen, so we're going to take oxygen, which has 16, we're going to multiply by 2, which is 32 grams per mole. Okay, so then we're just going to add this together, which comes out to, okay, so Mn plus 2O is, or O2 actually, because, that's part of the formula. And note that we're not going to use the coefficient right now because that's irrelevant, and that's going to be 86.94. Okay, now grams per mole. Now to find the number of moles, we're going to take how much of the element or molecule that we have and divide it by the molar weight. So it's going to be, so to find how many moles of aluminum we have, we're going to take 22 grams and divide it by 26.98, which is the molar weight of aluminum, and that comes out to be 0.82 moles. We're going to do the same for this particle, and that's going to be 13 grams divided by 86.94 grams, and that's going to be 0.15 moles. So in this problem, we have 82 moles of aluminum and 0.15 moles of manganese for oxide.
So it should be noted that the chemical reaction represents an ideal ratio between product and reactant, but in the lab we don't always have that at our disposal. So we have to and some of the reactant is often left in excess, so we have to calculate which is the limiting reagent, which means that which reactant gets used up first. And since we already know the amount of moles of each reactant, we can use the ratio between each reactant to see which one will get used up first and how much of the excess will be left over. So we know that we have 0.82 moles of aluminum, and the ratio between aluminum and manganese oxide is 3 to 4. So we multiply that by the ratio, and we get 0.61 moles. And what that means is that's how many moles of manganese oxide we need for the reaction. And we also know that we have 0.15 moles of manganese oxide, and the ratio between that and the aluminum is 4 to 3. So we multiply that, and that tells us that we would need 0.2 moles of aluminum for the reaction. Now, what we need to see is that 0.61 moles we do have at our disposal, and 0.2 moles we do not have at our disposal, which means that our limiting reagent is
manganese oxide.
Manganese oxide.
So we know that we have 0.82 moles of aluminum, 0.15 moles of MnO2, and since we have that equation, we need to use the ratios to see how many moles are needed in order to find the excess. And as Arslan already did, there's 0.61 moles of MnO2 needed and 0.2 moles of Al needed. So we know that Al, since we have 0.82 moles of Al is in excess. So we know that MnO2 is the limiting reagent. And we have aluminum in excess. So aluminum is excess. How much in excess exactly? Well, it's just 0.82 minus how many moles of aluminum is needed. So it would be 0.82 moles minus 0.2 moles of aluminum needed, which gives you 0.62 moles that are left over. But the question asks how much excess reactant remains, and they want the answer in grams. So we have it in moles. The way we convert moles into grams is that we use the molecular weight, grams per mole, multiply it with the moles in order to find grams. We already know that the molecular weight of aluminum is 26.98 grams per mole. So we take 0.62 moles, multiply that by the molecular weight, so 26.98 grams per mole, and plugging into a calculator gives you 16.73 grams. We round that up to 17 grams, and the answer is C.